Great. So today we are talking about information visualizations. We already talked about the data science, essentially the path that you need to take. You need to get the data, you need to clean them, and then you need to make sense of it. But at the end of like that, you have a good model. You want to essentially show it to others. We had some introduction into that with talking about Matplotlib, but I mentioned that we are talking more and we have a deep dive on it later, which is essentially in today's session. We talk a little bit more about visualization and in particular information visualization, which is very important to convey your results to the others. Good. So what is visualization? Visualization is something that actually, the idea of visualization goes to the dawn of humankind. So this is a way, visualization in general is a technique for creating numbers, images, diagrams, or animations such that you can communicate a message effectively or efficiently. And you can find very ancient ones, like for example the hieroglyphs in ancient Egypt, cave paintings, or very early maps. So you can see, for example, here they have, this is one particular like cave painting that these people try to say to the young generation, don't touch these spiky animals. So visualization was there, but here we want to talk more about information visualizations. And information is that, I mean, you want to convey more information. Of course, any visualization, you can say information, but here we try to go to the more modern way of information visualization, which would be essentially more computer sciencey way of that. But before that, some brief history. I mean, first known map that we know is the 12th century. Of course, up to now, maybe later we'll find some earlier ones. First presentation graphics that, I mean, was by William Playfair. And the first multi-dimensional representations appear in 19th century. So it is not like several dimensions, you have it and somebody has drawn that. Some famous people is William Playfair, as I mentioned. He's a founder of graphic methods for statistics and economics actually. And he's a famous person in the field. John Snow, he has the first cholera map in London. We will talk more about cholera maps essentially. And Charles Joseph Minard, he has the essentially the first visualization of Napoleon and the Russian campaign of 1812. And according to Tufts, the best statistical graphic ever drawn are these things by Charles. Of course, up to that point, essentially, now we may have a more effective way of doing that. But what about more modern visualization? The first one actually appeared in 1985. This is the National Science Foundation workshop on scientific visualization. Then there was a 1987 a special issue of computer graphics on visualization in scientific computing. That was some of the early important work. IEEE first visualization conference came in 1990. That was, I mean, like, for example, IEEE conference on foundations of computer science that appeared much earlier, maybe something like around almost 20, 30 years before this. In 2000, I mean, public media started to integrate infographics. Again, infographics means information, graphics that they have information into TV, newspaper, magazine, etc. And there is this particular article, Visual Analytics, that was actually very impactful article on this field. A visualization became very popular on social networks. Nowadays, the people also, I mean, try to communicate through social networks. And techniques such as HTML5, CSS 3, and D3 enabled more individualizations for essentially laptops and mobile devices. We will talk about this one later in this session. So why do we care about information visualization? So the main thing is that, I mean, nowadays we have the big data that grows more and more essential. At the same time, you can get essentially lots of or a large amount of data, visual data, processed using the parallel approaches that exist. Also, we have the advanced graphical software and hardware, which enables essentially doing large-scale visualization and data manipulation of interfaces. So in some sense, our tools become stronger for this purpose, both software and hardware, and the data becomes larger. So it means that now we need to have more research in this area. See, how can we represent this large data using this essentially more advanced tools? And that's the thing that more research people essentially came to this. One area which is very related to this in computer science actually became things HCI, and their main conference is called CHI. And this HCM is human-computer interactions that talks about essentially how visualizations, especially for like information visualization, can be done to make sense, especially for large data using powerful tools, both in terms of software and hardware. The goal for information visualization, one of course is the presentation. So you want to communicate a complex idea or insight with clarity, precision, and efficiency to others. That is essentially to your other stakeholders or to your managers, etc. in the company. The other one is exploratory data analysis, that you try to identify properties, relationships, regulations, and patterns for yourself. For example, a good example is that you may essentially find some kind of pattern in the stock market that if this pattern happens, then you should buy or sell. And there are lots of these kind of things. If you go, for example, for a stock market, there are others, and they are hiring this top Wall Street companies. They are hiring the best people in math, physics, or CS to just understand more this pattern, and they can make money. And you can do it even manually as well. This is more, the second one is for more for yourself. So the first one is more for others. Second one is for more for yourself. And the third one is somehow in the middle, confirmative analysis. So you have some analysis that you have already done, and you want to now support this analysis by showing essentially some information visualizations. And here you may compare to some things, or you may say that something caused the other things. All of them, you can show it with visualizations. And so it is somehow, it is more proving the things or do sanity checks. Somehow in between, both for yourself and for others. The first thing that you may want to do it, visualization, the simplest thing that you can visualize are by numbers. Numbers are just some very essentially like compressed way of representing this. So here, if we are talking about two important essentially machine learning approaches that we talked already, regression, that in which essentially you have a point and you try to, these are some of the points, and you try to find essentially a curve, the best curve, maybe in multidimensional, that passes through this, and you can predict what will be the next point essentially. If you give X, what is Y essentially. And the other one is classifications. In the classification, we try to say essentially decide between dog versus cat, or essentially dog versus non-dog. Non-dog means cat, cow, etc. So it can be essentially just binary, or it can be multi, essentially classifications. Binary classification or multi-case classification. But binary one is essentially the most important one, because even the multi one, you can always say, if you want to decide between dog, cat, and cow, you can say dog versus non-dog, cat versus non-cat, cow versus non-cow. So you can essentially represent everything with binary. Now let's go to regression. For regression, and we have a different visualizations in terms of number for them. These are super important actually to know that, because these are some of the things that the people will ask essentially in interviews, etc. And these are important for yourself as well. There are three error metrics commonly used for evaluating and reporting the performance of a regression model. And here we have two things. We have this y hat, which is the predicted data. And so this is y hat, essentially. And also, y is the observed data, and n is the number of data points. So this actually can help you in two ways. So one is that, when you try to consider different models, generally you are dividing your data into 80% for training and 20% for testing. So you may run different models, 80% there, and then these are the predictions. So you know the y values here, but you don't know the y values here, or you pretend to you don't know that you will get the y hat, the prediction, and then you try to compare them. Or sometimes when you have them fine, so you may test different model and say that, okay, this model works best. Then the real world is coming. In the real world, also these are the y's that you really don't know. And then you will say, what would be the error? Either way, essentially, you are using some of these things that we are talking here. So again, y hat is the predicted, this y hat is the prediction, the predicted case. Yi is the actual observed data, and n is the number of data points. One famous one is the mean absolute error, or MAE, which is essentially, which 1 over number of n, the number of samples. You just take the essentially absolute difference between your prediction and actual prediction. And this is essentially considered L1 norm. Take the average. There is another one called mean absolute percentage error, or MAPE. That actually maybe is a bit more even popular, because this just the values difference may not say the most important aspect of this. You divide it by y as well. Like y is the one that the observed data. So you want to say, what is the percentage of error in some sense? So it would be 100% over n, and this would be sigma of y minus y hat, the predicted one, over y. That essentially you will get a percentage of error. So MAPE especially is very famous. Another one is the root mean square error, RMSE, which is essentially this more like the L2 one, that you will take this differences power to the power of 2, and then you will take the square root. There is another one. These two are the most important one that the people are using it. And there is another one called R squared, or adjusted R square score. This to measure how much, the model captures the variance of the data, because you want to essentially see that this model you predict whether it has some variance or just giving one number essentially. This is the formula for that. It is 1 minus this yi. As I mentioned, yi is the observed data minus the predicted data over yi minus the average of yi's. So that's essentially you are taking how much variance exists in my predictions versus the actual prediction of the data. And these are the formulas essentially for that you can use it. That is used more for variance, probably less in practice, especially among these three. MAPE is very important. And also, this is important that there is some relation between this. In particular, you know that mean absolute error is less than or equal to root mean square, and it is less than or equal to n square root of n times MAE. So in some sense, RMSE is sandwiched between MAE. But here, the factor is really large into the square root of n essentially. So, but there is some relation between them. Good. These are the ones for regressions that essentially the y is the observed, this is some number, and y hat is another number, and you compare them. But for classification, as I mentioned, this is the case that you want to see say the simplest one, the binary essentially classification, that you will see essentially a photo and you want to say it is dog versus cat. So for this one, first thing that you need to know about confusion matrix, which is super important. So what is the confusion matrix? So essentially, we will consider the real things that happens versus the predicted things. And as I mentioned, you can always consider even the multi-classification, you can consider it as a binary. Positive means that essentially say this is the shape of a dog versus it is not the shape of a dog. That would be negative. Can be in case, for example, it can be cat, or it can be cat or cow. So positive means the one that you really care about. Another example is that, for example, some transaction happens, some credit card transaction happens, and you want to see whether this is a essentially fraud or not. Good. Now, so when you consider this positive, then you will consider real and prediction. Say that, okay, if the real, one photo that I'm giving, if it is positive, it's a dog, then the question is whether your prediction also is a dog, or maybe say, no, this is a cat or not dog. The negative one is that if it's not a dog, then whether your algorithm also say non-dog or it says essentially a dog. If it is, again, and then you are considering essentially both positive and negative case. So here, the first one that comes essentially to the play is the accuracy. What is the accuracy? So the accuracy is essentially says that, it is this is the ratio of true negative plus true positive. You say that, okay, so I want to know what is the accuracy. Among the positive guy, how many, what is the, like, so this is essentially how many of these cases you mentioned true positive and they were positive, or true negative, they were negative and you mentioned negative, over all other cases. The other ones are false positive, means that essentially it was negative, but you mentioned, your algorithm mentioned positive. Or the other case, that it was actually positive, it was a dog, but your algorithm says it's not dog. This is called false negative. So that you will take the ratio, that would be the one that you can get it. What is the problem? The accuracy is a very reasonable thing. What is the percentage that you have mentioned correctly? This is the problem. The problem is that consider the fraud case that I mentioned. For example, these are the transactions, the credit cards. You can say that probably 99.9% of these are non-fraud. And then say, I don't know, 0.1% is fraud. Typical case that we don't have a balanced data. Balanced data means that, like, essentially half of them are positive, half of them are negative. If it is the case, actually accuracy is a very good example. However, if it is very imbalanced, like this one, only 0.1% fraud and the 90.9% non-fraud, then what will happen? Your algorithm, the machine learning algorithm, can just simply say anything that it gets is a non-fraud. And then it is correct on 99.9% at least. Interestingly, if you want to change it such that you find these fraud ones, it would be very hard, because probably some of this 99.9% is also says it was a fraud or it was not a fraud. So beating this 90.9% through that is a trivial algorithm, says everything is non-fraud, is very hard. That's the thing that you need to do two things. Either you need to change your measure, or you need to make the data balance. To make the data balance, there is this two process of downsampling or upsampling, essentially. The downsampling is that, yes, if it is the case, it is fraud versus this, then of course you should have a large amount of data, but make sure that if the number of frauds are X, and you know that these are the frauds, then take essentially X samples from here, or around 2X. Not all of them, because you want to essentially make the comparison apple to apple comparison. Another way is that maybe if it is the case, then you may need to actually upsample this one. Instead of doing that, you may want to repeat this data, and like one data may appear more than once, such that anyhow this data becomes balanced. These binary things positive versus negative, they should be balanced. If it is the case, then accuracy is a good one. And you can make the data this, and then you see which model is. However, if the data is still in balance and you want to also get some other measures for that ones, these are some of the things that it is not that much related which are imbalanced. Although it is good to make it balanced if you can, but otherwise still you can use this formula. The one important, there are two things. The first one is precision. What is the precision? Precision is that how many true positive among those instances that your algorithm mentioned positive. True positive among all things that your algorithm mentioned. Recall is somehow dual of that. It says how many true positive among the real positive ones. So this over this, some of this is over some of this. And there is one which is called F1 score that actually combines both of them. You can say this is 2 times precision times recall over precision plus recall. You can actually write this one here over 2. It is somehow, this is more like the geometric, this is more geometric mean, this is more arithmetic mean. And one important thing, if precision and recall, if precision is equal to recall, what will happen? Then in this case, we have precision to the essentially precision square. Here we have precision plus precision over 2, which would be essentially precision. So it would be precision square over precision would be precision. So in that case, if precision and recall are equal, then F1 score also would be equal to that. So F1 score is somehow to try to capture both precision and recall. And as I mentioned, if both of them are essentially your algorithm correct, essentially in both of them the same number, then F1 score would be the same. There is another one more generalization for F1 score. It is F beta score. That is larger beta. So if beta is equal to 1, actually F1 score and F beta score would be the same. You can see that. However, you can see this formula, and if there are larger values of beta, then it put more weight on recall. So the formula here is that beta square times precision, but actually it makes sure that the effect of precision is less and recall is more important. You can actually put the numbers and check it yourself. It's a good exercise. But higher beta actually causes more weight to recall. Some people, consider maybe recall is, for some people, might be a bit more important because you are saying among the true positive guy, what is the percentage that you mentioned actually? But anyhow, these are the measures but all of this accuracy, precision, recall, F1 score, especially, these are all very common and you should know that. Another one, it is called AUC. This is some other thing that is used when the ranking is there, and essentially said that what is the percentage of the pairs that the ranking among this, maybe the number that you mentioned are not correct, but at least the rank is preserved when you predicted something. That's another one, AUC. You can also learn more about it and read more about it. That's also common, and some places actually it is used a lot. So that is good to know about it. As I mentioned, some places I have seen that the people actually doing that, but you can read more about it. Good. So these are the things for the numbers. So so we talk about overview of information visualization. We talk about visualization via numbers. Now let's talk a little bit more about the good versus bad visualizations. What is good and what is bad? And this is more information visualizations. Of course, the numbered one would be the one that we already discussed. Like, so somehow accuracy is not a good measure for imbalanced data. But for balanced data, is a very good. But let's see more things essentially. This is the book by Alberto Cairo. Say how charts lie. And you can see that, you can actually present the things And sometimes, I mean, they don't lie, but they don't give you the correct information. Sometimes they lie, actually. Here, this is some examples of good versus bad. For example, here, consider this one. This is a chart to say essentially something happened. It says that following cable regulations, there was 14 billion essentially dollar investment in cable essentially industry. But then when they relax it, and that was essentially the time that they will put it here. But when they relaxed it in 1999, then there was, in these 4 years, it was 56. That's a simple one, but it may not capture all the things. You can see a better one is this one. Cable industry infrastructure expenditures. You will see that in 92, actually, they put these regulations, and still it went up, actually, during this time. Even though they put the regulations. And then later, they essentially relax this one. When you relax it, at some point, actually, it went down. So it's not completely the case that it goes up, but generally it is the case that when there are less regulations, these are the investors say, oh, maybe there are less regulation. Now there are better, essentially, chance of ROI, return on the investment. Then it was a huge jump, essentially. And you may, when now you will take a look at it, see whether it was just because of this fact, or maybe there are some other correlated fact or that causes this. There was some causation. So you can get much better things from this diagram, from this essentially bar chart. This you can actually compare it with the, for example, the money that is invested, for example, after COVID, because everything becomes essentially remote. They put a lot of things, essentially money in the infrastructure of essentially internet. And then went down after COVID, but again went up now this time because of ChatGPT and the potentials of AIs. Then again went up essentially. You can actually, this is a good example is like, for example, Microsoft stock price. You can see exactly what is the trend, that it went up and then it went down and then again up. Like saying now it is over 380 or something, the highest ever. The same thing, similarities to Facebook as well. Good. There's another one. For example, this is the US production cost in terms of the US dollar per unit. This is someone that drew it like this, and essentially, this is very confusing. Why? Because this essentially, if you consider it essentially x, this is y-axis, was not essentially put correctly. If you put it correctly, essentially zooming, you get it much better results. For product 1, product 2, if you draw it according to this, you will see that actually this, for product 1, the cost was much higher, essentially. It is not clear here, especially when you are doing that, you are also trying to draw some curve, etc. In the lower scale, zoom out, you may not get the best things. This is another one. Music preferences having changed in 2 decades. So this is some study from the students at University of Miami. And they see how much from 1994 to 2014, the taste of the people changed, the taste of the students. These are the things that they liked at 1994. This is the 2004. Oh, it's actually a beautiful diagram, but there are some issues with that. The first thing is that here we have the numbers, but here we don't have the numbers. So we cannot compare it. Yes, we see it's a bit bigger, but it's hard essentially to see whether this is exactly this or not. And it is 5%, what is this? 3%, 2%, or what? Another issue is that, I mean, you cannot see the trend quite well. It is a bit just too complicated. The one that is much better is this one. This is called a slope, essentially, chart. This one is the pie chart. This one is a slope chart. And we talk some of them essentially that they are like this, like Matplotlib or other things. So here it said that essentially for each of them, it puts some line and said that, okay, for example, hard rock, it went from 1994 to 2014, it went from 35, I don't know, to 40. The same thing. So you see much less color. This is the one that we will talk about data ink. That there is much less essentially ink here used. If somebody wants to draw this versus the previous one, much less ink is better. You can get the whole things if this is the idea that you see what are the trends, that is much less ink and you can get a very good idea. You can see the trend, which one went up, which one went down, and how much. So in the previous one was much harder. So it maybe looks good, but it's not the best. Another thing, Planned Parenthood procedures. Somebody shows this one and just put the numbers, and these numbers say they are correct, but they just draw this diagram. What is the thing they try to imply? That when there are more abortions, then the cancer screening and prevention services went down. So that's, okay, abortion is not a good thing, essentially, to do. Of course, this is not the correct one. I mean, to do that, yes, somebody can put it, maybe the numbers are correct. But the actual thing that you should show it in the correct dimensions and the correct scale would be like this. If you see that, abortion actually went a little bit up during this time, this cancer servicing essentially went down, but it doesn't seem that there is much relation between that because abortion is essentially the same rate as before. Good. So this was the wrong one. This is the correct. And all essentially from this book by Albert that we discussed essentially. This is another one. 2014 median weekly earnings for full-time workers over 25 years old. Those people, this is like essentially the weekly earning, I don't know, $450 here, for example. And this is less than HS means that they don't have essentially less than high school, essentially education. High school education, then less than bachelor, and higher than bachelor. That both for men and women. It's a bit hard to compare essentially. Now look at this one. Again, less ink. We will talk more about it. It is called less dense, also the density. These are like very similar. Less dense has a higher data ink, means that everything has been used essentially for showing the data. Why do we need to put all these colors essentially? And you can compare it much better essentially between men and women, and you can get a good system. And these are the things that I mentioned. This is important because these are some of these visualizations that you may use essentially. You may implement it yourself, or someone that you supervise, it may implement it. And the person comes with like lots of coloring in the thing. We say, this is not a good one. You want to get, these are the principles that we are talking about it. And you see, these are deep dive into visualization. Not only how you can draw it, yes, you can draw this one with Matplotlib and etc. But the issue is the essence of it, whether it's a good drawing or not. And the people in the HCI especially, they spend time on it, understood this one, which one the people like the best. They have done lots of experiments on that. And based on that, they have some theories that we are discussing. So in some sense, here we are talking more about the theory of visualization or information visualization versus just drawing something. We will talk about the tools. We talked about the tools before about Matplotlib, but this is a combination. Another one is this one. This is the political wins. It says that nearly 90% of the wind capacity bought online in 2016 was in the states that voted for Donald Trump. Somebody shows that and try to, I don't know, reach a conclusion. But I mean, this is not a very, I mean, yeah, there's some color things and it is not clear what's going on. Versus a similar thing is like this one. Here, you want to say the Bitcoin wealth distribution in terms of the IPs. Each wallet that you have, it has some address essentially. And you can say that, for example, 90% of the addresses, the wallets have like 80% of the Bitcoin. And then for the others. So that is a much nicer one. Actually, you can get a good idea about it. Versus this one that is not clear. What do you represent essentially? Is it for different estates? Then if it's a different estate, why don't you say which estate is this one? Is it Texas or I don't know, Florida or others? What about the others? This is not a very good one, essentially. The person tried to just present it to get something out of it, but it does not show the trends, anything. Another one is this one. These are the polio cases, essentially, from 1930 to 1965. And you will see that when the vaccine is introduced, then it becomes less. Seems, again, nice diagram. Lots of colors. But lots of colors is not necessarily good. The issue is that, I mean, what's the relation between essentially, I don't know, blue versus yellow? It's not clear. The one that you can use it, these are kind of heat map that you may want to use. Now you can see much better, essentially. Say, oh, these are the things, it becomes red and this one. So there is some relation between these colors that you can show. Maybe still this is not perfect. Why? Generally, the people might be colorblind. And you can see after vaccine introduction, you can see it essentially disappears. But it's not the case. So then maybe say that some people are colorblind, so they cannot see red essentially. But maybe I can show this. Still, yes, maybe they can see it here, but still different colors. We don't know what is the comparison between them. This is the one that all good as a heat map and something good for the colorblind. Because still it shows the intensity and also use the colors which are for the people who are colorblind is like much better. See, these are the arts that is coming into play essentially. Of course, visualization always is about the art, but this kind of HCI or the websites, if you have a website which does not look good, it's not artistic, then the people don't come to your website. You lose the traffic. And if you lose the traffic, means you lose money. Traffic for a website is the most important thing. Because that proportional to that, you have customers, you can raise money, and also you can just show advertisement and get money. So it is super important that you have a very nice visualization. And again, this is always this question is that this is P versus MP that is discussed, I think, sometime earlier. But anyhow, you might be not a good artist, but at least you know what is good art versus bad art. That was the question with the person who knows good art versus bad art, whether he's an artist or not. This is a philosophical question. Or it can be a good artist. Another one, for example, polio cases in the United States is talking about different estates. For each estate, you are drawing something. It's very unclear. Which estate is this? What are these ones? This is the one, it is called small multiples, that they have essentially the same type of scale, but in lots of them. In different states, we have essentially different ones. And because they have the same scale, you can actually compare them. Among them, like if you just say Arizona, you can see what's going on, and you can compare it essentially with other ones. Compared to the previous one, it was not completely unclear. So sometime here, you may need to draw more to show something. Another one, visualization uncertainty. So this is a way essentially say Hurricane Cairo is coming category 5. What are the places that are affected? That's one way to show that. But the question is that what's the meaning of this? I mean, this is just some cone essentially. Then somebody is coming and just drawing a little bit more. That draws essentially some circles, means that these are some affected areas. And yeah. But the issue is that still not, so affected area, what's the meaning of that? This is slightly better. It shows essentially what are in the center, what are more scattered kinds of things that happens. But then the question is that, what about the difference between this case here and here? And whether if I am here, I'm not affected or I'm affected. Interesting thing is that this is actually a number that you should mention at least as a caption, that this area that we are talking, so cone is just 66% probability. It means that with 66%, like, or 0.66 probability, you get affected in this area, and then like the rest, you are not get affected. But it means that this is a probability. Still, you might get affected here. There is another one which is simpler, is something like this. You just draw this one, and this one says that, okay, this is the path, and then it becomes weaker, and here you see it becomes weaker. It means that this area also can be affected. Again, less color in some sense, but more information. This is the thing, again, we discussed about two issues. Density, you don't want to make it dense, and also data ink should be high. It means that data ink ratio. It means that this thing that you use it, any ink that you are using, you should try to somehow communicate some information. In other words, if something does not communicate information, just try to delete it. That would be better, because the people will be more focused on that. Good. So we talk about some of these things, good versus bad visualization. Now let's talk about some key concepts. So some of the things that we may use it essentially here are length or height. So we will consider, for example, these are some diagrams that we have it, and these are some kind of bar chart that you talk about the length of them or height of them, and this can be the lollipop chart also, that would be just the length of them. Position is the important thing. Where do you put it essentially? That's the thing that we will talk about, the reference system. What is the reference system? Reference system generally means X, Y essentially, or sometimes three-dimensional. Areas are important. You may draw it like this, you may draw it like this, the area. This has the area and also shows some kind of hierarchical structure. There are three maps that we will talk about. Angle also is important. For example, when you do that, these are for pie chart that becomes very important. Or line weight. So here, for example, here you have A, B, C, D, and this is some kind of I mean, they have some height, but at the same time, they have some essentially weight or width. That shows that how much is like essentially more word, for example, or more things happen during C comparing to A or B. Hue and shade, these are also very important. I mean, you may use a different color. There are some kinds of comparison between colors, and also, I mean, how much shade you are doing. These are also something it is important. And there are some standard way essentially. Like this is, they represent this percentage or something. Good. A good thing essentially for this one, this data visualization catalog, that is the website. You can go and you can see all these kind of diagrams there. We are talking about some of them here, but there are many more here. And they are giving the examples. That's a very good website to go and check essentially things. And the idea is that you need to be familiar. Again, this concept of artist versus the person. You might not be artist. You may not draw all of them, or you may. But at the same time, at least you can distinguish good versus bad. And that's the thing that you should know about it and suggest essentially good things. This is especially, I mean, happens more things that you may go on the Upwork or other this kind of thing that you are hiring some people, and these people are just coming and drawing some diagram for, oh yeah, I'm expert in this area, I can draw diagrams. And then you see, oh, this person is drawing, just putting lots of colors, but really does not know the theory behind this. That's the thing that you will be essentially have an edge to that person, that you know the theory of visualization or information visualization. And that's the thing that we will talk in this thing. This is things essentially based on Cleveland and Robert McGill. 1984. The people have a papers, and these are the theory of visualization that we are talking about. So here, this is the question that you want to present this one to whether the general audience or more essentially professionals. Then you may use different diagrams. If you want to get more accurate estimates for professionals, you may use this kind of bar charts, lollipop charts, diagrams, etc. When you try to do it more general audience, you just try to just show more shapes, shades, hue, etc. So you should say, who are the audience of your website? And we will talk more essentially. You may have a different level. You may have some overview for general audience and then some kind of zooming for more professional in a dynamic way. So these are some great for accurate judgment, comparison relationship, bar chart. We talk about it, lollipop charts, dot charts that essentially say that for this essentially what are the population at this time, a scatter chart, line chart, or a slope chart that we talk for the music. These are very good essentially. However, if you want to do more general audience, then essentially you are using more shapes, etc. And in particular, these are some of them for general audience that we will talk. So this is a couplet mat, dot map, proportional symbol map, and isoplet map. That we will talk more about them, but these are some that are actually for more general audience. Great, essentially for general patterns, trends, etc. Another thing that you need to consider. So the question that whether you want to do it for more professional or for more general audience. So these are all aspects of it that you need to consider, and based on that you can decide. The question is that different levels of analysis. Whether you want to show something for the whole world, macro level, or you may want to do meso or local or group level, medium level, or you want to do for the micro and individual level. Like for example, this is the example of this. So, and then the question is that what type of questions you want to answer. This is based on the framework by Berner, 2014. He is actually one of the pioneers in this field to understand the theory of them. Another person is Ben Steinerman, who is actually he's a professor emeritus at UMD, and he has also done great things. We will talk more about his theory as well. So here, this is the level of analysis, this micro, meso, and macro. And then this is the things that we are talking about, the type of question. So for example, if you consider the micro case, between 1 to 100 records you want to do it. And the question that you try to answer and a statistical analytical things. So this can be the case, like individual person and their expertise profiles. So it is a limited number of expertise that they can be. But it can be the case that you want to do it essentially in the meso level. Meso level means larger labs, center, universities, research centers, versus essentially the macro level, which is all national science foundations, all USA, or all science essentially. And then this is a statistical question. The question, this we will talk more about it. The question that you will ask, whether it is about when, means temporal questions, about the geospatial analysis, talking more about where, or topical analysis means essentially what, or network analysis would be whom, or with whom actually. This topical analysis, it would be more about the NLP that we talked in the previous lectures actually. Presentation, the one that I gave you the link for it. Good. So for each of these, who are the audience? Like who are, like this is what is the level of analysis that you are doing? and which question you will answer, you may use a different essential thing. And this is a theory. There are theories for that. We will talk some of this essential. There are two essentially comparing workflows. One, as I mentioned, by Berner, 2014. This is Visual Insight. We will talk more about it. This is like essentially currently the best standard for this. There was another earlier one by Fry, was visualizing data. So Berner essentially said that first you need to read the data, analyze the data, then you need to visualize it. When you visualize it, there are three things that you need to do. You need to say what are the visualization types that we will talk about it. These are some of overlay of the data. Overlay means how do we want to put them, how do we want to link together. We will talk less about it, and you can read more about it. Another one is the visually encoded data. What are the type of essentially visualizations that, what are the types of elements that you can use it? And then when you have it deployed. There is a corresponding thing, like the earlier one, like you say, it's talking about first acquiring the data, parse it, filter it, and mine it, then represent, refine, and interact. And these are some of this is corresponding to like read data. It means essentially these two steps together. But we will talk more about the Berner. This is the way it is called needs-driven workflow, that there are some stakeholders, they need some information, and according to the types and level of analysis that we discussed, like what is the level of analysis, micro, macro, or meso things, and you talk about level of this, and the type means when, where, with whom, what topic, whether it is a statistical things or etc. Based on that, they determine the data, algorithms, and parameters and deployment. So you need to get, based on that, you need to, these are the data that we need to acquire. Then you will read this data, you analyze this data, and then you visualize it. Again, for visualization type, different visualization type that we will use it. This is some overlay data that how do we want to modify this one, adding the links or connecting these guys together, and then visually encode data, which talk about the graphic variables type. We will talk more about this one, and also a little bit about this. This one is more, you can read about it. It has less theory about it. And essentially the first one and last one are more important. But let's talk about the visualization types. Now, for visualization types, these are the taxonomy by data types. What are the data types that we may have it? This is actually, as I mentioned, this is the one that is done by Professor Ben Schneiderman. He's an emeritus professor here at UMG. So he in 1996 proposed 7 data types to categorize visualization. What are the data types that you may have? It can be one-dimensional. One-dimensional essentially to represent information in a one-dimensional things. Examples that exist are like textual documents, source codes, name lists, etc. So essentially, when you see a text, it is one-dimensional. You will just come down, or a program, or name list. Some of them are two-dimensional. These are representing essentially in two-dimensional visual object. This is essentially you have X, Y, or you may have essentially maps. Here, these are graphics maps, floor plan, newspaper layouts, some examples of that. Some might be three-dimensional to represent information as a three-dimensional. Like, for example, for a protein, molecules, or human bodies, or building, etc. These are three dimensions. So 1, 2, 3. You can have multi-dimensional, more than that, but the issue that the people generally don't understand more than 3 dimensions. So in this case, you may need to embed them. There are techniques to essentially project them or embed them into 3-dimensional or 2-dimensional, something that the people can understand. These are lots of relational or statistical databases like that. Also, more than that, this is the other type of data. These are temporal data. So temporal data essentially is the one that they are talking about the time. And these are represent information based on a temporal order or some kind of time order. For example, if these are medical records, project management, or historical presentation, these are time also is involved. How do you want to show times? You want to show essentially, say, for example, how was Earth at different times. So that is another type of thing. Another one is a tree. Tree, as we discussed before, it is maybe to represent hierarchical relationships. Or more generally, network. Again, we talk about network X that can essentially show more complex relation than a simple tree can do that. Now, there is another one based on this. This is by Minard, 2014. Some of them, they have intersection. Like, of course, Schneiderman was much earlier, 1996. He has a more modern version, maybe this one. He said that we have charts in which there is no reference system, like Wordle, essentially, pie charts. So there is no X and Y for them. Tables, these are some of the things that we have actually charts. And we have some kind of categorical access that can be selected, reordered, and cells can have a color coded. A color coded essentially means that color coded generally means that, for example, if you have table, it is a two-dimensional thing, and you may have it essentially, say, red, non-red, such that the people can read it better. So these are the tables, these are two-dimensional. These are the things that they have access. Some of them, they don't have any access, just essentially no reference system. Reference system means essentially no XY. Then we have graphs. These graphs, they are talking about quantitative or qualitative access. These are some of these bar graphs, timelines, scatter plots, all of them, these are graphs. So not only, so this one, for example, a map, it can, or a table, it is like more this. A graph gives more information. Then we have these geospatial maps. They use generally latitude and longitude reference system, like for world or city maps. A good example of this is Google Maps, essentially. That it is nowadays is used by lots of companies like Uber, I don't know, Airbnb, others. Anyone can use it, actually. It's easy to use. But if the number of queries to the map becomes larger, then you need to pay Google. Another one is about the network graphs. So here, essentially, in the network graphs, just the node position, essentially, it depends on the node attribute or node similarities. So that decides about how do you want to position the nodes. Then you may have tree graphs that they are showing hierarchies, taxonomies, genealogies. Or you may have a network, which are social network, migration flows. These are more complex. So this is essentially the things that are mentioned by Barnard, even more modern things. Charts, no reference system, tables, and then graphs that they have more information, geospatial maps that they have some kind of essentially latitude and longitude system in the back, and the network graph that can be the positions of the node, whether the shape is a tree or essentially more like about a general network. So these are the type of the data visualization types that we have. Now the question is that, so how do you want to essentially, among these different types that we have, how should we do the selection? As I mentioned, there are two things. You want to say, what is the level of the data that you want to show? Is it like a small number, medium, or large? The other thing was what question you want to show, essentially. So the temporal one is essentially more time issues. Those that times becomes important. So temporal analysis and visualization answer the when question and can help to understand the temporal distribution of the database. So you want to say that essentially the time somehow is important in this representation and how you can represent it. For example, they can identify growth rate, latency, peak times, or decay rates. That should be shown, essentially. Also, they can show, essentially, patterns in the time series, as I mentioned, for a stock market. For example, they are showing the patterns of a stock, such as trend, seasonality, and birth. These are the three important, actually, terms that you should learn more about them. You can just search and you can get more ideas about them. These are very important in the temporal data: trends, seasonality, and birth. So some of these temporal trends that we are considering, some of them, for example, the temporal trends about, so it can be increasing, decreasing, stable, or cyclic. These are some of these that you can see. And the visualization type that we can have a line graph, we can have a stack graph, temporal bar graph, histograms, and small multiples that I will talk about them. So this is essentially line graph. This is a typical thing that you are showing essentially for two things. You can have it two different colors and you can do it. A stack graph. A stack graph is actually a nice one that it can show lots of information. For example, these are the names starting with A per million babies from 1880s to 2014. You can see the names that are starting with A, essentially their total number went down around 1950s. And it is not only shows the total because they put a stack together, but for each of them, for example, if you consider Ashley, you will see what happens essentially during this time. Or if you consider Abigail, you will see what happens during this time. So at the different times exactly. So not only shows individually, but also shows the total distributions. Another one, essentially, it is called temporal bar graphs. So this is something that shows prominent terms in tweets. For some events, essentially. It shows that, for example, this word event has been used from this time to this time. This is the beginning and end. And then the width of that, it shows that how much, what was the percentage that has been used. If it has been used heavily, like, for example, about this word, or, not that much. Event has been used, but it was not very popular during that time. It is called temporal bar graph. So you talk about beginning, end, and the width. It shows that essentially popularity. Another one are histograms. Histograms are essentially the one that are showing the distributions. For example, here it shows the distribution of ages for men versus women in 1956. It shows that, the ages here, at that time, the people were much younger. Then these people who were younger, they become essentially middle age. And here it becomes more, some people die, some essentially survive. It still is a bit heavy here, but not as heavy as here. And this is, what is the important thing about this distribution, we talk about it. So it means that the sum of the things here is equal to the sum here. Both of them are equal to 1, essentially. So the sum should be equal to 1 because it's a probability. Another one which are important, as I mentioned, if you want to show temporal things, are this kind of small multiples. Sometimes they call them trellis chart, lattice chart, grid chart, or panel chart. This is a small, this is a series of similar graphs or charts using the same scale plus axis. So essentially the axis and scales are the same. And you can easily compare them. So for example, this is for, I don't know, the salaries that these people getting in different fields, you can compare them essentially in different months. So this, and we also mentioned for polio or other things. Another question that we may try to answer, these are visualization type selections when we talk about where. This is geospatial. So geospatial data analysis and visualization essentially is originated from geography or cartography, but there are increasingly common in statistic, information visualization, and many other fields. And as I mentioned, a very common thing is because of Google Maps. Google Maps can show that, and then everyone is using Google Maps. Here we are trying to answer where questions. So we want to say the important positions or sometimes movement that happens in the geographical space. So for the general map, we have several things you can represent a map. Sometimes this is a general reference map. So here essentially it's say the map of essentially United States that you are drawing essentially something. These are the different states that you are drawing. And generally there is some reference essentially for that. This is the reference, this is X and Y. This is a general map, and lots of the time we just use that. There is another one called a topographic map. Topographic maps has this one, but on top of that also you will show. So these are essentially less details. Or for general audience, these are more details. For more professionals. Here in the topographic maps, although also you are showing something like man-made or natural features such as roads, railways, power, etc. That is on top of that. Another one is the thematic map. This thematic map, it portrays some important geographic patterns. It can be the physiogeographic that's showing essentially the earth surface and physical patterns like the mountains versus non-mountains, or socioeconomics that is are showing political boundaries, popularity, density, and voting behavior, or it can be technical, just mapping that shows navigation routes. These are like again Google Maps that they are showing that. So these are different type of maps that you need to decide when you ask the where questions, which one you want to do it, whether you want to do it for general audience or for a specific purpose. Some of this that I want to talk about them. One is the proportional symbol map. This represents data variables by symbols. And for example, here you may consider the number of COVIDs at some state in US. And then like the bigger circle shows bigger number of COVIDs. This is the one that is called couplet map, essentially. This represents, essentially, this has the reference system and shows essentially the densities, ratios, rates. And you may have a different, this is a heated map. The heated map essentially is the one that we talk about it, that more heat essentially becomes darker and darker. The only the main difference between this one and another one that we call it heat, or sometimes it is called isoplet map, is that here in the isoplet map, then you just have essentially, you just show some continuous data by different colors. And here, this is not restricted to the boundaries of the map. So here, when you do the US, then you don't show essentially the states there. You just show the patterns without going to the details of this. But here in this kind of the couplet map, you also show essentially the reference system, and for different states, you have a different essentially figures, like different things. So that's, but these are essentially, these are the same. These are more heated map. So these are some proportional symbol map that you have a larger and larger circles for more things, or you have some heated map essentially. Another one, it is called cartograms. These are more some kinds of cartoons essentially, that they try to show some things essentially, some thematic maps about some statistical information. For example, when you see that, really the shape of US is not like that. It's more like a cartoon. But you need to know you need to have some knowledge about these maps when you show them, to make sure that, I mean, the people are not confused. But there are some kinds of cartoons that they try to do that. It is called cartograms. Another one, this is a flow map. This flow map actually is very, that shows the path that our intangible objects takes to get from one geospatial place to another one. This shows movement. For example, here you want to say the so here it is talking about the scientific collaborations from 2005 to 2009. And you will see that essentially these people are collaborating more from this one, or these people are collaborating more. This shows the flow and the movement of this map. Another one is called space-time cubes. This is good if you want to show histories. For example, you want to show the entities, locations over time. This is the one that essentially shows that each cube here shows a particular time. Or so here, for the number of planets that the people knew at any time. At different time, the people know more about the planet that around Earth exists, and this you can show it all of them in one map. You can show the history essentially. Another thing that we will be used a lot is these are kind of things that about the topicals. Topicals essentially those that they are answering the what question. questions that lots of them come from the text, the one that we discussed before, like in the previous session about word-to-vec stuff, essentially, or the text NLPs. All of them are the things that are, if you ask some questions about some text, you may need to show some kind of topical diagrams. And these are essentially to generate this visualization from text processing or natural language processing. You can use the tools that we already talked in the previous session, natural language analysis with NLTK or SPACY. These are the two famous ones for essentially working with the NLP or natural language processing or the text. There are some maybe newer ones, but these are still used a lot to get some information about the text. So for the topical, the text stuff, these are, again, some things that you may want to use it. These are the charts. So we are going essentially according to this burner things, that charts, what are the charts, what are the tables, graphs, geospatial maps, and network graphs. So here, there are some examples. One famous one, when you are talking about the topic, you want to see what are the words that appear in this. Like here, for example, IMDb movie titles. But if you use Wordle, you can always draw. So in the title of the movie, what words has been used a lot? Maybe man has been used a lot, a star, or other things. Good. So that's the thing that you can get it from the Wordle. This is the word clouds. Then the other one is the text overlay. That's this is by Abbasi and Chan. I mean, as I mentioned, so when you have essentially a text, and from this text, actually, you may use from this text, you may want to understand something. You may want to run some ML algorithms, essentially, to get some information. Those important words, you have it non-black, and those that are important features among them, it essentially you are using the red colors. I mentioned something like a Shapley value. This Shapley value is the one that essentially, when you have an ML model, you can say what is the importance of each feature when you are doing feature engineering, and that's a global way to do that. And then according to that, you may put it essentially more larger circles here for the words which are more important or more heated, essentially. So as I mentioned, this griddle is another one that uses categorical and hierarchical access to support categorical zooming, so you can zoom on different things and get the things. Maybe used less nowadays. This is this periodic table. So these are this periodic table, essentially, which is used to organize elements, sharing similar elements. A common example would be essentially when you are doing for chemistry elements. This is a very famous use of this. This one that I talk about, circular visualizations. Circular visualization, I will talk more about it. And this cross maps, these are the things that you have a different, essentially, paragraph. So here you can see that, for example, for different text, you will have, this is for different text, different words. So that for this particular text, how many times this word has been used, you have, if the number of times that is used more, then you are having a larger circle. That's a cross map. I mentioned about circular visualizations. These are the good ones, essentially, that here, this is from the William College majors to carrier. These are the majors and these are the carriers. It's a nice one that it shows that if the people, for example, who got their degree in English, they went more to laws or the K-12 education or this one. You can actually zoom in a dynamic way as well, and you can see the flow there. It's a very nice one that you can represent nicely the thing that's happening. Another one is the topical. This one is the self-organizing map that you try to give some metaphors or cartoons. This is for different part of the body. You will put essentially different figures, different islands, and then you will show them. Another one is the concept map, that is essentially the network that connects the concepts which are similar to each other. You can read more about them as well. Last but not least, about the visualization type through networks. So here, we try to answer with whom question. The with whom question can be answered by tree or network. And for the trees, we may have radial trees and tree maps. And for networks, we have this random layout, circular, and other things that we will talk about them. So this is the radial tree map. For example, this is that you are showing as a tree structure in which when you expand, you will go out. Here you can see that the president of the company, which is generally called level 12. Then these are the SVP or chief officers that are level 11. Then VPs that are level 10, and so on and so forth. And then you can show it essentially in this circular map. Or this is another one, tree maps, that is got actually from the University of Maryland. This says the different sectors of the university and how big each of them and what are the different parts of it and how many people are in each of them. So that shows both the hierarchies and how big each of them. How big is each of them? So this is if you want to show the networks, you can have the random layout, just put the people, essentially the nodes as random points. You can, of course, use network X to draw that. It is very fast and it shows the size and density. Another one is a circular, very similar to that, but you will just put all the nodes in the circles, can provide some kind of sequential information. If somehow these nodes are connected, in some sense, that can show this one. And it's very fast. Another one is essentially this kind of forced direct layout, that you are putting similar nodes near to each other and far nodes essentially far from each other. It utilizes similarity or distance relationship among the nodes. Another one is the bipartite layout. It renders when we have two types of essentially nodes. As I mentioned, this is a good example would be riders and drivers or Ubers and the relation between them. Or if you want to show at this point, what is the relation between them? Or you may want to see essentially shoppers versus sellers at Amazon. So these are like essentially for Uber or for Amazon, you can show them. Another one, it is a subway map. We have seen this one before. Generally, subway map is a good one, that here you try to evenly distribute the nodes. And you have generally uniform edge lengths, and these are mainly orthogonal. Orthogonal means either essentially horizontal or vertical. Sometimes you have this kind of diagonal as well, but a few. They are actually showing, the good thing is that they are showing the different essentially flows, that if you want to, for example, do this first, you need to do this, then you need to do that. They show essentially some sequence very well. And this sequence, that's essentially the concept of metro or subway map, that you can see these are the steps, you can actually represent it quite well. And there is another one, is the network overlay. This is generally the one that you will put it on some geospatial maps. It uses a geospatial reference system to place nodes. So it is a network on top of some kind of a geospatial reference system. Here, for example, for airport traffic, you can say from Chicago, what are the places and how many essentially, what is the flow and to which places there's a flight from Chicago for this particular airline. This is the network plus some reference map. And good. So far, we mainly talk about this kind of visualization types, that when you want to do that, you want to say what are the number of records that you are doing again. Is it macro, micro, or meso? And also what question you want to answer. The question is that when, where, what, and with whom. These are the important questions that, depending on that, you may use a different thing. This is mainly by Berner. Berner essentially mentioned that these are the things that you can do it. Based on which one you want to show it, you may use a different thing. I want to talk a little bit about the graphic variable types. That's also interesting. So some of these graphic things that we are using, we need to know about the data scales. So when we talk about the data, we may have some data essentially. Some of them are more qualitative. So you need to say what are the type of the data. Based on that, we may use a different variables, graphic variables. Some of this data that we have are more qualitative. Some are more quantitative. Good example. So when we talk about the categorical, this is some kinds of the subject things. These are mainly, these are more word stuff. A good example of categorical are words or numbers constituting the names, description of people, places, things, and events. That's a good example of like categorical things. This is essentially when we talk about the classification, we generally talk about categorical things. And these are more like, as I mentioned, more qualitative. Then we talk about ordinals. Ordinal is essentially say somehow about the rank. It still is not very numbery. You say that this is better than that. And these are like ranked order values. A good example of this would be like, for example, days of the week. There is some order on them. Degree of satisfaction, very good, good, neutral, etc. Like ranking such as low, medium, high. These are ordinal. A little bit more somehow quantitative. Then these are intervals. These intervals these are the things that they call value scale. These are, you want to say that, for example, how much you like this website. You can say that 0, then you can say 100, or you can say something in between. These are, like, for example, temperatures in degrees. So you will show some degrees, essentially. Or like, for example, when the prices, you can say the price of the stock is between, I don't know, $10 versus $30. And so this is the price. This is from 20 to, I don't know, 40. That was the min, this was the max, and this is the current thing that is 35, for example. These are intervals that are used, essentially. And last but not least, are this ratio. Ratio essentially means just any numbers, weights, height, essentially reaction times, etc. So, and again, these are the data. You need to say this, what is the type of the data that you are showing? It is more qualitative or more quantitative. And based on that, you may use a different graphic, essentially, elements. That is, again, these are the theory that is built on that. You need to say it is categorical, ordinal, a little bit more quantitative, then interval or ratio. So for more quantitative data, you may use the positions. Positions becomes important. Where do you show it, essentially, the map? What is the size, essentially, in the form? What is the lightness or brightness? And then these are some patterns, rotations, coarseness, size, etc. we are using. For qualitative, you are just using more shapes, essentially. These are high levels, essentially, again. Orientations may be good. Some hue, you are using different colors because you want to say for different words, you may use different colors. Or you may use different optics, etc. So depending on that whether it is more quantitative or qualitative, you may use different type of graphics, essentially. Good. So, so far, we talked about aesthetic visualization. What's the meaning of aesthetic? It means that you are just showing something, some diagram, some chart, and that's it, that you try to give it the best. But sometimes you try to interact with this, essentially, map. And that's the thing that you may try to zoom in, zoom out. These are more like a website. There you may show some chart, but also you want to interact more, essentially. And then there are some theories for this. These are like the websites. Sometimes you want to just show some diagrams. Or these are like some part of your website are aesthetic, but there are some parts which are dynamic visualization. So, and next we will talk about this kind of dynamic visualizations. Great. Okay, so far we talk about aesthetic visualization. As I mentioned, this is like some chart that you want to show in your website. So the question is that what about if you want to show something more interesting and more interactive. That's the thing essentially dynamic visualization is called. Of course, I mean, one way essentially to make, this is the way to make cartoons. You will make these different aesthetic things, and then you will put it essentially side by side and like as an animation. You will go through them. That would be one way to make dynamic. But that's not the type of thing that we are making. These are like the cartoons. These are original cartoons have been built like this. We are talking more essentially more advanced techniques. In which considers the interaction into the design system. So it said that, okay, the design for this web page should contains essentially interactions. And in particular, I mean, some of this is very useful is D3.js, as well as in general, JavaScript is the one that it is good for this kind of, it is something which is very good for this type of dynamic things. We will talk more about. So Schneider's mantra. So this is actually from the user interface interaction that immediate interaction that the users can have not only should allow direct manipulation of the visual object, but also should allow users to select what to be displayed. So this is by Card et al. This is the thing that they had it in their paper. And these are, Schneiderman actually has, in 1996, summarized 6 types of interface functionality. So you want to have some kind of, so if you want to design it, the whole website essentially or dynamics, you should have some overview. Then you should have some zoom and filtering thing that you will just show some particular thing or focus on something. And then you want to have details on demand if you want essentially relate to some previous things that you have seen and the history of the thing that you have seen it. But these 4 parts seems more important. So overview first, then zoom and filter next, and then the details on demands. That's essentially the way that you can do it. So again, so this is the idea that first you try to give some overview about the whole things. And then, so in some sense, there are 2 things. You will give the overview about the whole thing, and then you can focus on some part and essentially see more details on that. This is the 2 interaction approaches that have been used. And these are, again, these are the things that lots of papers are there essentially. The people are thinking about it, what should be the way that you do it, especially as I mentioned, in this kind of, for example, in HCI community, like Chi conference. So HCI is the community, human-computer interaction, and Chi is the most important conference there. The people are publishing essentially paper there. And there are some different theories that are there. I try to just, I mean, we cannot go through all the papers, and these are new papers, of course, are coming based on the new experience. But here I want to give some interesting things about this. So these are the 3 important things that you need to consider when you try to do this kind of dynamic visualizations. First, it should be effective information presentation. You should give the information that you want. You should give it to the people. Then you should avoid distraction and confusion. Reducing cognitive load. So these are like, if you want to do essentially any visualization, aesthetic or dynamic, you should try to first effective to show the important information. The important one you should not miss. Then it should be avoid distractions and confusion because these are not good. try to essentially be minimalist. And then finally, last but not least, adding some aesthetic values or like artistic value. Then you can also want to also make it essentially nice and artistic. For example, if you have this reference system, you don't want to put something like this. That is not very artistic, essentially. In some sense, you want to, some principles which are important are this one. Beauty of visualization. And all of them are important because if this is a nice website, then you get more traffic and you get more money out of it. Beauty of visualization, I will talk about it. Data ink ratio that I mentioned before, but we will talk more about it. Data density, very similar to data ink. A color heuristic and Fitts law. So this is a book, actually, beautiful visualization. These are 4 criteria that is mentioned to have a visualization which is beautiful. First, it should be informative, as I mentioned. So it should be successfully convey the information. It should be efficient, means simple, focused, clear, and straightforward. It should be aesthetic, means that you should access layout, shape, colors, etc. in a nice way. As I mentioned, it should be somehow proportional, and the person is looking at it, say, oh, it's a very nice one. And the last but not least, which is, I mean, this we already talked, the last one is the novelty. Is that you should be creative and attract readers with new design. That's the thing that happens. The people, if you have a new design, the people like these are cars. They are copying the ideas of the car from each other. The website, the same thing. If you have a nice website, everyone try to do that. Then at some point you are unique, everyone use that, but everyone becomes like that. Then they are going and changing essentially. You need to once in a while change it essentially. That's the thing that you will go to the bank, you go to, I have a Chase Bank, and say, oh, the design has been changed. I hate it at that time because I got used to it, but maybe after a few tries, then it becomes essentially more, I mean, interesting, hopefully, for me. So these are important. And some of the best example of this essentially are the Google pages. If you say Google search, you will see it is the case. This is like the first thing is essentially just the search is there. It is very informative, just search essentially. Then it is very simple. It's not, does not have lots of essentially, I don't know, nonsense stuff, essentially colors, just blank, some white blank, and then something for the search. At the same time, this has some aesthetic or artistic things. They have a logo that changes every day. And at the same time, it's a novel, essentially, and they kept this one, and they make it, they change it also slightly, but still it's every day is novel. That you can consider it also with Amazon. Amazon is a bit different, essentially. We see they are actually, there are fight at Amazon to get a slight part of the page. And you see the whole thing is full of the products. Again, both of these companies, these are trillion-dollar companies. And they have actually the same values almost. And the issue that both of them, of course, they have the money for the designer to do that. But sometimes for something that works well and the other one works there. Again, even Amazon tries to be minimalist at the level, but they think that, okay, if we can put more related stuff, we can get more. So in some sense, they are still informative how they are. This is one of the most important one that I mentioned, data ink ratio. This is mentioned by Tufts. So they say that the data, Tufts say that a good graphical representation should maximize data ink and erase as much as possible non-data ink. So what are the non-data ink? Are scale, border, etc. Essentially, it means that if something you can, so what's the meaning of that? What's the meaning of data ink? It means that if you consider this web page, you will print it. What are the parts that are data? What are non-data parts? You want to increase the data ink ratio. So essentially, say data ink ratio is that the data ink, those, if you print it, what parts are data? What parts are non-data? You want to maximize this ratio. This is a good example of this. This has the low data, this one has the low data ink ratio. you have lots of colors, etc. This one does not have it, and it's much nicer. Actually, this is something that if you see, for example, at Amazon versus Google, both of them have this one. One is more full page, blank things that is like this, but the other one is full. But it is still does not anything. It is information there. The other thing is the data density. The data density of a graph is a proportion of the total size of the graph that is dedicated to displaying data. It's similar to data ink, but there's some differences. You should have also very high data density. What's the meaning of that? This is again from Tufts, actually, 1983. He says that most graphs can be shrunk away down without losing legibility and or information. So it means that if you want to show something, don't pick it like a very big things that show something. If it's still legible, you can read it. Make it a small, such that it looks better, and such that, because in some sense, when you make it big, then you try to use anything that is a graphic. It takes some part of or causes some confusion actually for the reader or for the user. So then don't do it. Just leave it blank and just essentially focus on the data that you want. And that's essentially similar. So for example, if you have some data like this, the people can read it. You can do it like this. The people can read it, and you can have it like this. Of course, here you have the zoom capability. The people can zoom. But the default one, don't make it so big. Make that essentially smaller. Another thing is the color heuristics. Use contrast and analogy principle. So contrasting colors means they are different subject or different things. Analogous color means these are similar. And you should use these principles. So contrast draws more attention. Analogy shows groups. So if there are some analogous things, these are the same group concept. If there are contrast, different colors means that these are different things. A color coded, sometimes the people are color coding. Again, mention that, for example, a table, this is a table of data, then for each of them, they are using different colors, such that the people can do it. But you should be essentially make sure that if you do color coding, that's the way that I mentioned, you should keep legibility. The difference between foreground and background should be clear. For example, this is one that is good, and this is one that is bad, essentially. Like you see, the contrast of color, here it is shown the contrast. This is like the one that shows the contrast as well. These are some of the data that you have. This is the one that essentially in the color coded, but you cannot read this part. This is another beautiful thing, Fitts law. So this is especially for dynamic websites. So not okay. So the amount of time. So you have your mouse here, and you want to go to this one to click here. So you bought something, and then you want to click order it or something. The amount of time required for a person to move a pointer or say mouse cursor to a target area is a function of the distance. So this is trivial. If it is from here to here, that takes time essentially. The distance is higher, then takes more time. But this is the part, interesting thing. It says that it is not just the distance that is important. This is the distance to the target divided by the size of the target. It means that if I want to go from here to here, versus if I want to go to here, they have the same distance. But going to here, it looks to the people, this is like some kind of cognitive thing. You feel, oh, the distance here was much less because you want to go to higher objects versus the one that is much lower things, essentially. It is essentially again, these are the things that the people thought about. This is a theory. Before that, I didn't notice that. I said, oh, that's actually correct for me if I want to create it. So if you put something, then don't put arbitrarily the buttons there. You need to be careful. If you want to do that, if the distance is high, at least make the other object larger such that the distance looks smaller. There's a formula for that, but that is essentially, as I mentioned, the idea that. So essentially, it says that Fitts law shows that to shorten the movement time, or at least the perceived movement time, and lower the index of difficulty. So it would be difficult if you want to go from here to here, and these are far from each other. So if you go high distance, essentially that's the index, the difficulty would be higher. To essentially make the index of difficulty lower and essentially shorten the perceived movement time, what you can do that, you can shorten the distance to target, of course. Don't put it, if there's something related, put them together. Another thing is that the group functions or bottoms together to reduce redundant movements. The second one, enlarge the target. If you need to move it because of any reason, then make it that one large such that the people can see. This is perceived movement time that you want to make sure that the people, oh, it was not that thing, it was not far from. Good. So that's essentially about some laws about like beautiful design, how you can do it, colors, contrast, essentially, data things, data density, and Fitts law. These are some, again, theory that the people built in this community of HCI for having a better interaction with a human, a computer, and a person can essentially communicate better. Last but not least, we want to talk a little bit about some these tools that exist for us. So lots of this, essentially, this D3 visualization is something comes from InfoViz 2011. They have this one that, okay, you want to draw this one, all of this nice thing, for example, this circular one or others. There are tools for it. These are similar to the Python packages that you can do it. However, and these are the tools that you can use it. I will talk more about it, but these are the different things that you can do it. But let's talk a little bit about, again, some history here. So if you consider the web, there are some important parts. These are like more essentially front end I'm talking about. There is HTML. Still it was there, and I mean, back in essentially 20 years ago, it was there, still it is there. Same standard. Then these are HTML for the page content. This is the information. Then we have CSS for aesthetic. These are for the artistic things you are using CSS. Then we have JavaScript. JavaScript is the main thing for interactions. All these things that we will talk about, D3 and others, React, all of them are, say, D3. You need to include D3.js. Or you may need to include, I don't know, for example, React.js. It means that everything is in JavaScript. And that is for interactions. All the interactions happen with JavaScript. And last but not least, these are SVGs for vector graphics. What are this one? This is the important thing that we will talk about. It. You can actually draw nice figures by just text. That's a useful thing that you can use it for SVG. So this was essentially from the beginning. This was all this design that this was the whole field of HCI somehow based on this concept that how can make the interactions nice, essentially, and what are the theories. There are something that has been done. There were give you some ideas about it. So this Netscape was originally introduced JavaScript, and so JavaScript is one important thing that you can use it to do interactions, essentially click and then open Zoom, etc. There is not much a similarity to Java. I mean, maybe there is some in terms of writing the things, but mainly this Java was a hot topic at that time. So, okay, how can I do it? Call it JavaScript. Some similarity in terms of writing, for example, but it is more like C++ as well or C as well. Then there was this prefuse. This was a Java-based web visualization by Jeff here. That was actually important. After that, the people tried to use essentially This was another thing. It is called proto-vis, but that was at the end it was not good. They tried to give some very theory, some abstract way to do that, but the people say no, it is not that easy to do that. Maybe that abstract is not that useful. You want to do it a bit in the design. You need to consider it more. These are some of the works that have been done. This work in 2011 resulted the D3 that still is used by lots of people. There are some other packages that I'm talking about it, but this is also used. And still it is widely used. As I mentioned, how there are new packages. So one thing which is important about JavaScript. JavaScript is something that, what is the compiler for JavaScript? Is your browser. So in some sense, this is a language that it is very similar to Python. Python also is an interpreted language. It turned into C++ or C, and then you will get it. You don't go directly to machine language. This is the same thing. This is something that interpreted by your browser is the compiler for that. What is the good things or bad thing is that's a good thing is that you can run it essentially because the browsers are compiler. You will run it not at your site, at your server. You will run it on the mobile of a person or a laptop of a person, etc. So the person who is seeing that. What is the issue? The issue is that everything is obvious. The people can see the code. And that's the main source of essentially attacks. Because as I mentioned, I think I mentioned earlier that when this is a JavaScript and this is a code that is doing that, it interacts with your backend. But you cannot guarantee that this one that is doing is really your own front end. It can be any essentially adversary or malicious player that just essentially somehow mimics the approach that your front end contact with your backend, learns it, and then try to contact. And it is very hard actually to make it like when you make it executable file, then it becomes much harder to see what is inside. Still, there are some approaches, but much less. Here for JavaScript, also you can make it non-readable. All the variables, there are something that you can compile this JavaScript and make it, again, not just make it, for example, all the variables that have some meaning in your actual source code, it makes just use A, B, C, D or something like this. And essentially there are things that you can compile it and make your JS as much as possible, the code unreadable. But again, there are tools that they can make it readable. So you will just give this one, then make it readable for you. So there's no way to hide essentially. That is one thing that actually is happening about this thing. So we are talking about D3.js, but there are some others, for example, charts.js. This is another one to draw. DS and especially D3 and charts are some good ones. These are, I think, both of them. Charts are free. I think DS3 is also free. You can use it and you just include it essentially one line that say that use the chart.js or D3.js. In some sense, all of them are based in JS. It seems like a new language, but these are just functions based on JavaScript. At the end of the day, everything that you will do that, you will use React. You will use essentially this jQuery. All of them will go into become JavaScript because that's a language. But this seems actually a new language, a new compiler. But at the end of the day, you need to compile to make it the JS. That is also one thing. So the same way that for Python, there are lots of packages. For JavaScript, if you want to do it, also there are lots of packages. All of these D3, JS, React, Bootstrap, all of them are different packages that you can use. And you can just include one line, if you use that one and uses all of the techniques that are there, all the functions that are defined there. The only thing is that this community, we have, of course, a lot of people. For Python, there are Python packages, the concept of open source. That lots of open source packages that you can use. For this JavaScript, also there are such kind of packages, but not as much as Python. And there's a reason for that. Why? Because lots of these things essentially is to make the whole website more beautiful. And this means that these are not only computer scientists involved. Generally, there are graphists and other people are enjoying. They are not that get used to it to give it for free, the things. Generally, this is the idea that if you want to use some of this, they have a very nice one for charts and the new ones and others that you can use it for charts. But when you try to include them, the default is that if you want to use them, it is fine. You can just include them, but they have some kind of essentially watermark or something like this. Oh, this is from this company or something. That if you want to remove it, give us the money, then you can essentially, that is the removable version. Of course, this is the good thing is that it's JavaScript. You can do whatever you want. You just remove that watermark. What is the problem? Again, because it's JavaScript. Now, if you are just using it for your own website, nobody comes to your website, that is fine. But if you become a popular thing and you remove the watermark without paying them the money, they can come and sue you because everything is clear. You may change these ones a little bit, but there are something that they can compare these two programs easily. And these are some of the things that you will hear. For example, Oracle sued, I don't know, Google or something. Especially for JavaScript would be much easier to show that you have copied that thing without the copyright. So that's the problem, that essentially this you will find more that you need to pay essentially if you want to get very artistic ones, beautiful ones. Sometimes you need to pay money. Maybe not much, but this is the difference between this and the Python thing. But still, you may use it, and you don't want to draw all of them. The people have drawn this, but you need to pay essentially to use it. Good. So I want to go briefly about this. You know about them, hopefully, because of your project, but I want to just give you a general thing, and we are essentially done. So HTML and JavaScript basics. HTML is the hypertext markup language. There are some key elements. These are the headers, I think essentially HTML links. These are the title, body, and these are H1 to H4. These are the different fonts. P paragraphs, UL means unordered list, OL means ordered list, LI means list. This EM means essentially italic, strong means bold. A means when you want to refer to some other things. Span is that you are changing the style of something. And very important one is div. Div essentially some kind of makes the whole thing is like some kind of hierarchical things. So you have a whole page, you have a different division on each of them, you have a different division. That somehow is the idea of that you make different part of it. This is like more tree maps that I talked about. These are the divisions, different division. Each division has the different division, and you are doing that. This is a particular thing. For example, it is written, this has the list, and these are the ordered list, etc. So all HTML elements can be assigned attributes as property value pairs essentially. These attributes are, and there is this concept of classes and IDs. So what are the classes? So the classes essentially, these are the one that you will define them in the CSS file. These are mainly essentially so these are some variables. For the class variable, you can essentially say that it's using this particular artistic things that you have defined it, for example, in the CSS file. So CSS file, you will define them and then you can use them essentially. So this is the different things. These are the different classes that you can use it. So this is the classes which are very important. Which class you want to use it. These classes which shape, what is the artistic thing that you can use it. You can have a different, for this class, you can have a different values, and based on that, the shape of this would be different. There's another one, as I mentioned, div is important. You have lots of div inside. The other one is the ID. ID is very important because for any essentially variables, for any elements, you can have a different ID. And this ID would be useful because when you try to change it, essentially some properties of that, with JavaScript, you need this ID. This ID is very important such that you can come later and change these things. You can think about this one, the whole thing, that this is some HTML is there. And then there is this JavaScript, is some kind of some background program, essentially. We had some essentially program at the background. Something happens, one of these functions, which is essentially some event happens. According to that event, you define which function should become active. And then that function goes and changes part of this website. How does it change it? Sometimes it may hide something, essentially. How does it hide it? By these IDs. And you can define the division. When you get, for example, ID of this particular ID, make it hide. It hides, essentially. You don't see it anymore. So everything, essentially, that you are seeing is just one website that you just change it. And these event handlers are this JavaScript. These are the functions that are mentioned, so that if you click the mouse here, then it changes the website like this. And these are somehow these functions, the different functions that you have written, these events are waiting for something happens. When happens, the first event happens, then it changes this, you see a different look. That's the idea, essentially. So there are the best tools, essentially, for HTML and JavaScript. There are lots of things, but the best one is the Chrome. If you say Chrome and then you say inspect, you can go there and you can do lots of things. There are some compilers for that. Another one that I have mentioned is this CSS. This is for artistic things. And also to define classes, you can just use them. I mean, you can define, for example, here, this essentially is to dictate visual presentation. These are the artistic view or aesthetic view of this one. The document object model, essentially DOM means the main page. The DOM means DOM means the whole page that is there, and you are just changing it. So here, for example, you define P and L like this. This is for the paragraphs, and list, use this one. The font size, this should be this. The line height should be this. The color should be this. For the body part, this is the background color, this is the color. So you will just essentially divide the things, the whole page, into header, body, etc. And then based on that, you change essentially the color or the background color. So if you do that, that changes the whole things. If you want to essentially change one particular thing, you may define some classes, and then you will go and then find the ID of that element that you want and change this class such that it change the color, etc. So these are the CSS selectors, essentially, that you can these are the important things, essentially. You can, for each of them, you can change the format. And again, if you have the ID, you can just change those IDs that matches this. You don't need to change the whole list, essentially, to with this size, with this particular font size. Yeah, so these are about the CSS, and these are like, you can read more about it. I don't want to go through this one more, but these are actually the best things to do. This is W3 Schools. This is a very good website, especially, it is also, they have the different languages, but especially for HTML, JavaScript, and CSS. They have essentially very nice website. You will go there, they give the things, you can change anything that you want, you will see the results right away. You can just go and then anything that you want, you can find it there. Another thing that we want to talk about is about this SVG. This is scalable vector graphics. This SVG is essentially based on XML. We talk about XML is a generalization of HTML. This is something that you can draw graphics, essentially. If you want to draw this one, you can just write this line of code, and you will say what are the size it should fill in, what are the gray size at the background, and what is the size. You can draw everything essentially with this text. If you want to draw this one, then you will draw this one. But the good thing is that now you can turn everything into text. Even all the images, it will be in the text. This is very fast to process. And you can use this one, essentially, you can draw something and use it, for example, in LaTeX or others. And also you can search. If you want to search something, you can give the IDs. You can do lots of things when it is text. So in some sense, you textify the images. This is used also a lot. Good. So as I mentioned, so this one, we talk about JS. And then we talk about HTML. JS is not, I mean, the people like over time, this is like C++ versus Python. Say, okay, C++ is good, but Python, maybe you can do it much easier. This is the same thing. JS, everything still works with JS, but there are something on top of that. D3 is one of these. This is especially D3 JS is the one that is good for drawing charts, but not only charts, you can do some other stuff with D3. Essentially, you can change the whole DOM things. It has been generalized. Originally was for the charts, etc., but you can do more. This is another one, as I mentioned, charts. JS is mainly for charts, but this one is essentially used. So this D3, there are similar things that have been done. For example, jQuery is another one. jQuery is another language that you may do it. I have used, I mean, I have written lots of websites. I didn't use it that much. You don't need to use it because you can just use the JavaScript and you can do this one. These three is this one. You can just restrict the use for some nice figures or nice charts. Don't use it for the rest. And you can do this one with different things. So for example, here, if you want to, a simple transformation that change the color paragraphs white, essentially makes them disappear. So what do? This is by JS you will write it. You will say that variable PS, this is the list that you get document means the whole thing essentially. Get elements by tag name. Those things that a tag name is P paragraphs, get all of them as a list. Then essentially go to the length of this list and get the item out of it, and then change in the style essentially is the one that changed some properties of them. A style set property color to white. This is one that you can do it much simpler with just essentially CSS. Just say P color white, but that changes for everything essentially. This is somehow the background of this, you will put it in CSS, but that changes for everything. Every paragraph will be like this, unless you change it. Another one, you can use it jQuery. jQuery, generally, you have this $sign. You will say that all paragraph in the CSS, I mean, the paragraph in the CSS, color of them makes white. jQuery essentially is a bit, seems different language. You need to learn about it, but I mean, it takes some time to essentially be professional. But there is no need to do that. Also, you can do it with D3. D3 has some, D3 is more like functions that is written for Python, for JavaScript. Say D3, select all is a function that selects all paragraphs, and the style of them makes, in the style of them, style has some other thing, font, color, etc. The color of them makes white. So that is D3. So there are something that D3 cannot do it essentially. For example, does not support older browsers. And if you want to use it with Google Map or something, it might be not the best essentially. And essentially that doesn't hide the data. This is the same issue, but also for JavaScript. That also does not hide it. So it's nothing special about D3. This is essentially the last slide. These are some D3 basics. As I mentioned, the D3, you can select something. There are some operators that you can, essentially, you will select something and you will change the style as we have seen it. You can do essentially bind the data joins, you can do it. Another thing that is, you can do event handler, but event handler is nothing new because the JavaScript also can do that. So they are essentially inherited there. There are some transitions, help module. Again, if you want to use D3, probably you just use JavaScript. That is equally good. But in some sense, the D3 use, maybe you can do it in two parts. If you want to really do charts, you can get charts.js.org. That's actually a very good one, and you can use it, and you can do it for free. It's more open source. The other things, if you want to, this is the state of the art, is React.js. React, what is the idea of the React? Again, everything on JavaScript. But this is something on top of JavaScript. Interestingly, it seems a different language. It is now more like essentially actually object-oriented language. You have classes, etc. But the catch is that when you want to do it, you will write it React. You need to compile it to get the JavaScript, and that JavaScript is the one that you are putting as essentially front ends. So the browser, they cannot compile React. They can compile JavaScript. But this is somehow the language. It is like Python on top of C++. You can do that. The good things about the React, it is the most useful thing, is that you can, this is one of the issues, that you have some kind of essentially website, and you want to use lots of these things from one website to another one. Then the issue is in JavaScript is horrible to copy paste. It's, HTML is essentially very hard to read in some sense. That's the whole idea, that the people try to get something HTML plus JavaScript, essentially make it in a much nice format. React is the best for this one, that you can define some components and then you can reuse it. Another good thing about it is that it also allows you, I mentioned the novelty is a very important thing for websites. So you have this website, you want to change something about it. Then if this is something is written just JavaScript, it's very hard to change it. However, it is a React, because these are the components. You just go change one thing, it changes all elements of this. So these are essentially the hereditary property, or everything that is inherited, this even also changes, because there is an object-oriented. So these are the best state of the art is React.js. And this is, again, interesting. I have done this one. I learned in a hard way. I tried to do it. Then I went first with JavaScript. Then I used Bootstrap that was a bit nicer. But I said, oh, I want to use this component later. So, okay, maybe I should have used React. And then I understood actually top companies are all using React. And if you use React, you can use some classes which are Bootstrap, for example, or other things, other styles you can. Because if you want to change the style, it is very easy. You just change the style from this to that. Lots of structure still remains intact. Essentially, you don't need to change anything. So React is the best thing. Chart.js, you can use it essentially. I have used it. That's a very nice one. It is free. You can use it. Of course, you can use D3 or jQuery and others, but these are not necessary. React, if you can do it, that would be one of the best. Good. So I stop here.